This part is about tabular data sources, and we will go over some significant updates in traditional ways that you've gotten data into Wolfram language, such as import of some various formats like CSV and TSV, but also the introduction of these new structured formats that are very efficient for dealing with much larger data than something like CSV or TSV, which are text-based. We also have some updates in spreadsheet and statistical formats and some new functionality that will allow you to more simply connect to your data no matter where it is. So first, we'll talk about the significant updates in CSV and TSV, mainly performance improvements. Historically, we've had flexible and powerful functionality that seems to just work, and this is no exception. Bringing huge tabular data into the language is just as simple and flexible to code as you would expect Wolfram language to be, but it happily brings in your huge data sets no matter where they live. So in this CSV example, where we have 2 GB of data and many rows and columns, the the performance increase is nearly 30 times faster from the data element to bring the data into tabular now. So importing as tabular enables performance that was previously unreachable. And now workflows that used to take minutes are down to seconds. We're also not just improving the speed of the functionality, but the kind of automagical behavior that you've come to expect from Wolfram Research. Headers will be automatically recognized, including even information about their types. And this is the type of thing that will continuously improve over time, even though it's quite robust already. And we can do something like just grab a very large CSV file, and why don't I just give it a try? Wow, it's already done. That was, well, for the first 3 rows, quite fast. Wow, how long is it going to take for this very large file? Wow, also quite fast. And we're able to very quickly scroll through all of these rows. As you can see, no matter how many rows are here, it's very responsive with large data now. And you can also explicitly give data that doesn't have an obvious header. Like here's just a matrix where there wasn't a data or header included in your data. And say that we wanted the first line to be considered the header, you can just explicitly specify that with header lines goes to 1. And this is now your key column for the tabular object. And like I've mentioned, there's also type inference. So despite the fact that CSV is entirely plain text, when we bring this into a tabular object, you'll notice that age is already interpreted as integer 64 and survived is already a Boolean. And it's very easy, and with many of the methods, to convert these data types or specify the ones that you want given a tabular schema. So if we import this tabular and take a look at its types, we can see that we actually have properly imported integers and Booleans. And now, again, since tabular is a homogeneous type column object, every single column here, every item in the column, every element will be of the same type. And we also have improved missing detection. So if your data comes in with a variety of missing values that are represented as something like null or NA, these are typically automatically detected with no additional work. And you can even modify this behavior using missing value pattern. There's some backwards incompatible changes in import and export of CSV, but this is absolutely a feature. We, mentioned before, dataset is it's a data model that is hierarchical and can be extremely flexible. But in order to achieve the performance, the raw performance that's needed for modern workflows, we are heavily focusing on CSV and TSV being absolutely cutting edge. And the workarounds to your existing workflows are very simple and documented in the possible issues section. The new formats that we introduced are really exciting. The performance is really incredible. Every time that I've had to interact with data in the wild that I've gotten in one of these formats, things really were quite simple. So if we look at these formats, the first note is that they're columnar by default. Tabular is the default element for these formats. They allow you to store columns of various types, and that those types could even include arbitrary Wolfram language expressions. And we support various compression methods. So here you'll see that this flag column is an inert expression indicated by this little blue bracket badge in the corner. And these are actually Wolfram language graphics. And string columns will be indicated by this little double quotes. The other columns will be kind of obvious in the fact that they're either numbers or have some sort of unit. Now, if we go down to arrow IPC, this is based on the arrow in-memory format, so no translation is necessary between the file representation and the in-memory representation. What this means is that we can use memory mapping to avoid deserialization, and we can also pass around tabular data internally to heavily optimize workflows. Typically, arrow IPC files don't use any compression, but that means that kind of in your in-process workflows, when you're referring to the data, it's at full speed. We're already taking advantage of using it in our operations under the hood and will continue to. And we also support files and data that are either efficient for streaming data or for accessing the file randomly. Different workflows will have different ways that you want to save your data or that your data comes, and we are strongly committed to supporting all of those workflows. Parquet, this is the format that I end up using the most. It's a maximal space efficiency. It's optimized for disk I/O, has very good compression ratios, and even though it may be slower to arrow IPC due to the compression and decoding needed, it's often really nice to work with the file sizes and still quite fast. ORC is very similar to Parquet, but supports fewer column types. And in a quick performance comparison here, we can see that, compared to CSV, these formats are still significantly faster because they're able to be stored so efficiently. But even compared to previous versions, these types of timings for such large data, 2 GB of data, would not have been achievable. So let's look at updates in spreadsheet and statistical formats. Similar to CSV and other formats, all these spreadsheet formats, in addition to these statistical formats, that might be relevant to your domain more in particular if you use a lot of SAS or SPSS. But basically everybody has some Excel data somewhere. We have this tabular element now, which will bring the data directly into a tabular from even an Excel file. There's a tabular association element, which, had I not asked for the first one, would give you an association of the tabular, the name of the sheet, and the image is the name of the sheet, which is also imported as a tabular. And when possible, it still has automatic header detection. The last thing that I wanted to go over briefly is data connection object. And what data connection object is a object, a symbolic representation to some remote resource such as Amazon S3, Amazon Blob Storage, Dropbox, etc. So you can create a notebook with your remote data sources kind of at the top of the notebook. It provides authentication or a dialogue so you can give your own credentials and then pass the notebook to somebody else, and your colleagues can work on the same data but use their own credentials. This has control over refreshing when you pull in the data or getting locally cached results. And our list of supported data sources is about to grow faster than ever. This is seamlessly integrated with import, and I think that the integration will continue to improve over time. So let's take a look at what it is. We have a data connection object. This is purely a reference to where the data might be located and hasn't done any form of authentication. As soon as you work with the data connection object, say to get its file format, because this is referring to a remote file, Parquet is the file format. We can just call import directly on it, and it's retrieving the resource remotely. Using a data connection object, what we're hoping is to provide a workflow that whether your data is on some SQL server or in some remote location, you can do an entire one-line analytics such as aggregating the expression types. For each expression here in this expression row, we can get the mean of this numbers column. And I don't think that there's a syntax out there that's as efficient or simple as this.